Here's example 3 of using double angle formulas. So the question here is to evaluate, or the problem here is to evaluate cosine of 2 times the inverse sine of negative root 3 over 2. Okay, so remember, when you take the inverse trig function of some number, the result that you get can be thought of as an angle. So this is really cosine of 2 times some angle. So it looks like, since we have this 2 in here, it looks like we might have to use a double angle formula. Then remember, those are on this formula sheet here. If you want a copy of this, check the video description. There's a link. You can click that link, get a copy of this. But actually, we're not going to need any of these formulas for this problem because the inverse sine of negative root 3 over 2 can be evaluated directly. Okay, so always check for that first. If you can evaluate some inverse trig expression directly, go ahead and do that. And we did talk a lot about inverse trig in earlier videos, so we don't want to dwell too much on the details here. But anyway, let's just go ahead and get started with this. So if we want to evaluate 2 times the inverse sine of negative root 3 over 2, let's just look at this first by itself. So inverse sine of negative root 3 over 2. Okay. So we have to think back to our properties of inverse trig functions, things like that. So we can call this theta. Okay, so inverse sine of negative root 3 over 2 equals theta. So that could be called theta, and we'll say, okay, which theta, which theta in the range of the inverse sine function. So remember, theta has to be in the range of the inverse sine function. And what's the range of the inverse sine function? It's negative pi over 2 to positive pi over 2. Okay, so which theta in this interval has sine of theta equal to negative root 3 over 2? Okay. And the answer is it's theta equals negative pi over 3. Okay. Because sine of negative pi over 3 equals negative root 3 over 2. Okay, so that's really just a matter of knowing the unit circle and knowing properties of inverse trig functions and things like that. So we did talk a lot about that in earlier videos. But anyway, that's this tells us that this theta here is negative pi over 3 because the sine of negative pi over 3 is negative root 3 over 2. Therefore, this is negative pi over 3. Okay. So we have to be careful about this range here. There are infinitely many thetas that have sine of theta equal to negative root 3 over 2, but there's only one such theta inside of this interval here. Okay. So that's why we have to restrict to this range here, because that's the range of the inverse sine function. So only look between negative pi over 2 and positive pi over 2, and negative pi over 3 is the only one that satisfies these conditions here. Okay. The conditions of having the sine equal to negative root 3 over 2 and being in this interval here. Okay, so anyway, if we go back to evaluating this expression here, then what we have is cosine of 2 times the inverse sine of negative root 3 over 2 equals cosine of 2 times, so the inverse sine of negative root 3 over 2, we just found out that that's negative pi over 3. So that's 2 times negative pi over 3. So this is cosine of 2 times negative pi over 3 is negative 2 pi over 3. Okay, now from here we can just kind of think about the unit circle and go straight back to that, or we can just say, okay, well, hey, cosine is an even function, so cosine of negative theta equals cosine of theta for every value of theta. So cosine of negative 2 pi over 3, that is the same thing as cosine of 2 pi over 3. Okay. So it's a really, really nice property of even functions. It's especially nice for trig functions, for the even trig functions anyway, cosine and secant. So let's erase this here. Okay, now this right here is just a matter of straight up knowing the unit circle. So cosine of 2 pi over 3, that is negative 1/2. Okay? And that is the answer here. Evaluate cosine of 2 times the inverse sine of negative root 3 over 2. The answer is negative 1/2. So that's example 3 of double angle formulas, and we actually didn't use any double angle formulas at all. Okay, we have a double angle in here, but the point of this problem really is, even though you have a double angle, 2 multiplied by some angle in here, you might not have to resort to these formulas here. Okay, you might be able to do something a little bit simpler, and in this case the simpler thing was just direct evaluation. So we did have to remember some stuff about inverse trig, which wasn't too bad, and then we just evaluate directly, remember some stuff about the unit circle, that's pretty much it. So no double angle formulas involved, but we will see some examples coming up soon where we do have to use double angle formulas. Alright, so that's example 3, and again the answer is negative 1/2.